Welcome to Construction Math. Today we're going to be talking about adding and subtracting matrices. So for bell work, on your note taker, think about what symbols that you see around your world as you're going to school, as you're going home, at your job, in commercials. Write down what you see and add at least 2 to your note taker and tell what they mean. Share with your neighbor. Teacher, please pause the video until students have completed this task, and I'll meet you back here in a minute. Welcome back. All right, the objectives today. So on your note taker, fill in the words that are in red. We're going to determine whether matrices can be added or subtracted. So that's a question. Can they always be? Because we know numbers, we can always add and subtract whole numbers. Number 2, we're going to learn to add matrices. And number 3, we're going to learn to subtract matrices. All right, so think about that. We've talked about matrices in a previous lesson, and we're going to look at them a little bit more today. All right, so math check. First of all, for question number 1 is what's the dimension of that matrix? Question 2 and 3 are just doing some basic computation. So teacher, pause the video, have students work these problems on their note taker, have them share with their partner, and call in non-volunteers. I'll meet you back here in a minute. Welcome back. Let's see how you did. All right, the matrix is 3 by 2 because there are 3 rows. Rows go horizontally by 2 columns. Columns go vertically. 14 plus negative 3, the signs are different, so we subtract and keep the sign of the biggest. So 14 plus negative 3 is 11. Number 3 is a subtraction problem. Remember, we don't really subtract in math. We usually add the opposite. So it becomes 27 plus a positive 9, which gives us 36. All right. So let's continue on. So adding and subtracting matrices. It's important that when we add or subtract matrices, they have to have the same dimension. In other words, they have to be the same size. And what we do is add or subtract the corresponding elements. So if an element is in row 2, column 3, we would add or subtract it with the element in the second matrix in row 2, column 3. And I'll explain that a little bit further in the next one. So here we go. Here's an example, adding and subtracting matrices of the same dimension. Are these two the same dimension? Well, yes, they are, because they're both 2 rows by 2 columns. If that's the case, then we can add or subtract them. All right, that's the good news, because sometimes we can't. So, do they have the same dimension? Thumbs up or thumbs down? Hope you said thumbs up. All right, yes, they both are 2 by 2. So let's go ahead and see what we're going to do. So now what I've done is put circles or geometric shapes. They're 2 by 2. So in the first one, if we get row 1, column 1, we get negative 2 in the first matrix. In the second matrix, we get negative 3, and we add those positions together, and we get negative 5. So please add that to your note taker. Okay. Now, what do you think you should add next? Look at that example. And what should you add next? Which elements should you add next? Pause the video until students have an answer. Call on non-volunteers, and I'll meet you back here in a minute. Welcome back. All right, we would add row 1, column 2 to row 1, column 2 of the second matrix. So I have yellow triangles over there. So 5 plus 4 is 9. They're in the same position. And then what I did was continue on. Here we go. To get the 0 in the answer, I added these rhombuses in light green because I was really feeling creative. So 3 plus negative 3 is 0. And then I added these diamond-shaped ones. I'm sorry, the green ones really should have been parallelograms because these are a little bit more like a rhombus, but it's okay. Negative 1 plus 5 is 4. So they both have the same size matrice at the end as the 2 in the addition problem. So let's look at these. You take a look at this problem and decide. We're going to add or subtract. First of all, are they the same dimension? Okay, think about it. Discuss it with your partner. Okay, and here's the answer. The answer is no. The first matrix is a 2 by 2. The second matrix is a 3 by 1. They're not the same dimension, so they cannot be added or subtracted. So what you would do on this problem is say, can't work it, cannot add them. And that's kind of fun when that happens. All right, you try these. Teacher, pause the video and have the students work these 3 problems, add them to your note taker, and work them. Remember, if they cannot add or subtract, then you say can't do it, can't add them, or can't subtract them. So I'll pause the video. After you finish them, compare with your partner. Teacher call in non-volunteers, and I'll meet you back here in a few minutes. All righty, welcome back. Let's go ahead and go to the slates and see what we came up with. All right, first one. Let me draw my matrix. Remember they're bracket symbols, and let me get my problem down. All right, the first row in the first one was -5, -9. The second row is 2, 6. And the third row is 4, 5. And they want us to add to that the matrix negative, they want us to subtract. Let me make sure I get the right symbol. -9, 4. And then the second row is 7, -3. And the third row is 9, 0. So the first thing I'm always going to check with, are they the same size, the same dimension? I have 1, 2, 3 rows by 1, 2 columns. And this one has 1, 2, 3 rows by 2 columns. So that's possible to do. So I know that my answer matrix is also going to be a 3 by 2. So I'm going to have 3 by 2 right here. Now, this says subtraction. In algebra, when you subtract, you really add the opposites. So to make it easier for all of us, I'm going to change the subtraction to addition and change everybody's sign inside. That way I just have to add. Remember, 0 doesn't have a sign. So first of all, I add -5 plus +9, and I come up with +4. I add -9 plus -4, and I come up with -13. Next row, I add 2 plus -7 is -5. Notice they're in the same positions. Now I add 6 plus 3, and I come up with the answer of 9. Last row, I have 4 plus -9 gives me -5, and I add 5 plus 0, and that gives me 5. There's my first answer. So we did fine there. Now let's look at the next problem. The next problem is a strange looking matrix. It's 7, -1, 0, -5, and I want to add to that the matrix -9, 3, -1, -9. All right, so this has 1 row and 1, 2, 3, 4 columns. So this guy's a 1 by 4. This guy has 1 row and 1, 2, 3, 4 column. So it's a 1 by 4. So we can add them. So here we go. We just add the guys that are in the same position. 7 plus -9 is -2. 1 plus 3 is 2. 0 plus -1 is -1. -5 plus -9 is -14. And there we go. There's our answer. Pretty simple. I bet if you had to come up with a way to add matrices, you probably would have thought of this too. Since nature doesn't have matrices, they're really something that human beings thought of. It's kind of nice that they thought of something pretty logical. Now, I'm going to clear off this one, and I'm going to go to the last one. The last one said my matrix is 1923, if I could just read a little better, -40. I go 1/2, I go -92, and the last entry or the last element is 3/5. This is a 1, 2 by 1, 2, 3. His size is a 2 by 3. And I want to add to that this matrix. First row is 4/9 and -5/6. Then it's -13 and -6.4. And -1/2 and 0. So let's see what this one is. This one has 1, 2, 3 rows by 2 columns. They're not the same size, so it's not possible. This rule only works for adding and subtracting. When we get to multiplying matrices next semester, you'll see a little bit differently. But if they're not the same size or dimension, you cannot add or subtract them. So let's clear this out. Let's go back to my PowerPoint and let's just check that when I did these problems, I got the same answers. Looks like I did. And on the bottom, I says cannot add because the matrices are not the same dimension. If you just say not possible, I'll go fine with that. All right, now let's look at an application for construction. At the big box store, the foreman wants to maintain his inventory in matrices. And actually, matrices are quite old. They were invented around the 1800s, and they were the precursor actually to a spreadsheet. So what I need you to do right now is add the missing numbers that are in red for the inventory. Store A had 72 2x4s that are 8 feet long and 142 2x4s that are 10 feet long. They had 25 2x6s 8 feet long and 23 2x6s. 34 2x8s 8 feet long and 29 2x8s 10 feet long. And then store B had 68, 98, 21, 15, 29, and 28. So please just add those to your note taker. All right, so pause the video until everybody's done that. Welcome back. And so what I want you to do is on your note taker, write me a matrice for store A and a matrice for store B. All right. Pause the video and we'll be back in a minute to check. Welcome back. Let's see what you got. Here's what I got for store A. Notice, because this is real life, you need to label your rows and your columns. So I have 2x4s, 2x6s, and 2x8s. The columns are 8 feet long and 10 feet long. Now remember, you could interchange them. You could have had 2 rows, 8 feet and 10 feet, and the columns being 2x4, 2x6, and 2x8. But this is the way I chose to do it. So let's see, I probably should have kept the same kind of system for store B. So let's check. Oh, I did. The size of the lumber are the rows and the length of the lumber are the columns. So double check that you got those right. All right, so let's see what it wants us to do. Now it says take those 2 matrices and, if possible, add them to compute your total inventory. All right, so teacher, pause the video while the students do that and have the students compare with their partner and check, and I'll meet you back here in a couple minutes. Welcome back. Let's see if you did it correctly. All right, I added the 2 matrices. I made sure to label, at least on this, I didn't have quite enough room, but at least I labeled the final matrice or the answer matrice, and I just added the corresponding elements. So double check that you did them correctly, and I'll meet you back here in a couple minutes. Welcome back. Now, here's a question for you. How much more does store A stock? So we want to know. Remember, difference means subtract. So pause the video, and students, please do this on your note taker. Subtract the 2 matrices. Remember, it's important which one you put first because subtraction is not commutative. Order matters. All right, pause the video, and I'll meet you back here in a couple minutes. Welcome back. Let's see how you did. Here we go. I subtracted it. I put store A minus store B. I subtracted the elements, and remember, the simplest way to get that arithmetic done is to change the subtraction sign and change all the signs in the second matrix. And we're done. 672 minus 68 is 4. All right. Pause the video if you have any further questions or need to check a computation. Welcome back. Here's a you try. The Best Construction Store has 2 outlets in Phoenix and Tucson. Among other things, it sells bags of mortar, it sells blocks, and it sells bricks. All right, so please fill in the missing values on your note taker, and I'll meet you back here in a minute. Welcome back. So now what I need you to do is find the change in inventory. So you're going to take January sales and subtract it from February sales. All right, we'll pause the video while you do that. Welcome back. And here's my answer. I had February minus January. The changes are, in the first case, it was a positive value, but we can have negative change. We could have sold more than we did the month before. And so this would be your answer. Double check. Pause the video if you need to, teacher, and I'll meet you back here in a minute. All right, here's your closure. On your note takers, put down 3 important terms that you need to know about adding or subtracting matrices. 2 ideas or facts you would like to know more about, and 1 skill or concept that you have mastered. And I'll meet you back here for the next construction math video.